Welcome to Hope Academy. My name is Mr. O, and today I'm going to be going over the concept of asymptotes. And so when we talk about asymptotes, there are three different types of asymptotes that do exist. So I'm going to make sure to write that up here, asymptotes. And these asymptotes, what asymptotes are, before I go ahead and tell you the three different asymptotes, are basically, it's imaginary lines or imaginary lines in which the graph will never cross. And so a lot of times what I mean by that, just to provide a little sketch, is that sometimes you'll see graphs where there's a dotted, like where of course it's not going to show the dotted line, but you're going to see graphs that forever get near to those dotted lines, but will never cross them. And so they sometimes will look something like this, okay? And so when we talk about asymptotes, there are three types that do exist based on the, polynomial based equations. And they're horizontal, vertical, and oblique, or sometimes I've seen the term slant asymptotes, okay? And so for these three, there is actually a shortcut that does exist, and I personally believe that memorizing this shortcut will make your life so much easier. This concept is especially important for pre-calculus and in AP calculus, or just calculus in general. And it helps you a lot to predict and sort of sketch how graphs will sort of look. And so based on these three rules, three different type of asymptotes, I'm going to teach you how to memorize this based on a little shortcut that I learned along the way. And so I'm going to go ahead and explain them. So the first one I'm going to go over is vertical asymptote. Okay, and for vertical asymptotes, there's actually only one rule that does exist. And the way we find the vertical asymptote is that we make the denominator equal to 0. And what I mean by making the denominator equal to 0 is this. So let's say I'm making up this type of question, and I'm going to ask you for the vertical asymptote. So let's say y equals to 2x squared plus 5x plus 6 over, let's say, x squared minus 1. Okay? And so a lot of times when I talk about denominators, and as a potential review, we must remember always that this is my numerator, the upper part of the fraction, and this is my denominator. And so when I'm talking about denominator equals to 0, I'm actually going to take this value out and actually make it equal to 0. And so to solve it, of course, I could use factoring, box method, which I do cover in a different video. So feel free to review that if you're not sure how to go about doing this. And so I'm going to make this become equal to 0. Each part equal to 0 like this, and solve. So plus 1, x equals to 1, minus 1, x equals to negative 1, and these are going to be the values that exist for my vertical asymptote, okay? And to sketch it out just in case you want to see it in visual format, what it's going to look like then is that at x equals to 1 and negative 1, so then just create a little more line, there's going to be a dotted line that looks like this, because this is the vertical orientation that does exist. And there's going to be imaginary dotted lines right here. And so that sort of is how you do the vertical asymptote. But this is the most simplest one to remember. So I'm going to go ahead on another separate sheet of paper and explain the other two types. So there are two other types of asymptotes that do exist. And as I mentioned, there's the horizontal asymptote. Horizontal asymptote. And in order to do horizontal asymptotes, there are actually three rules that do exist, and each of them have their different ways in order to exist, dependent on the type of question you're dealing with. So the first rule is this, okay? It's the fact that and I will explain more in depth using examples of a problem, but when highest power of numerator equals to highest power of denominator, use coefficient. Okay, so it might be a little confusing at first what I mean by that. So I'm going to actually create a problem just on top of my head, just sort of to iterate what I mean by this. So let's say you're given an equation, y equals to let's say 2x squared plus 5x plus 6 again. I'm just making it up, but let's say it's 3x squared plus 9. Okay? So let's say I was given this question and I asked you, what is the horizontal asymptote for this question? The part is this. When I mentioned that the highest power of numerator equals to the highest power of denominator, I'm going to look at this equation and see, well, looking at all three parts, I see that 2 is the highest power that does exist right here. If I look at the bottom one for the denominator, 2 is also the highest right here. So after I confirm that the numerator power equals to the highest power of the denominator, I'm going to get the coefficient. So I'm going to ignore the rest of this whole equation and just notice that the front coefficient is 2 over 3. So that means that y equals to 2 over 3 is going to be my horizontal asymptote. And that's very helpful for me because it skips a lot of the extra steps that do exist normally in the horizontal asymptote work. And it just automatically, I can identify 2 over 3 because it's a front, what we call the coefficient numbers. And on a sketch, on the graph, if I was to sketch this once again, 1, 2, 3, 4, 5, 6, it's going to be 2/3, which I'm going to just create like sort of like a dotted line. It's not going to hit 1. It's going to be near it, but it's not going to hit 1. It's a dotted straight line that goes through this. And then that's what my horizontal asymptote is going to be for this question. But that's the first rule out of 3. The second one, to continue on. So the second rule is this. When the highest power of numerator is greater than highest power of denominator, no horizontal asymptote exists. Okay? And so I'm going to provide an example of what I mean by this. So the example for this case will be here. So let's say y equals to, let's say, 3x squared plus 5x minus 1 over x minus 3. Okay? So if I asked you, what is the horizontal asymptote that exists? I'm going to look at this question and notice, well, 2 is going to be the highest for the numerator, but for this denominator, 1 is actually going to be the highest, because if it's just x, that means the power is going to be 1. And because the numerator is greater than the denominator right here, that means for certain that there is going to be y equals to na or ak, we could just state no horizontal asymptote. And that completes my work for this question, okay? So that's the second rule that does exist. And there is one more rule that does exist based on horizontal asymptotes. And rule number 3, when highest power of numerator is less than highest power of denominator, horizontal asymptote will equal to 0. Okay? And so just to provide an example based on this scenario that I just mentioned, so example might be when I say y equals to, let's say, 2x minus 5 over x squared plus 3. I'm just making up the scenario. When I see this, if you notice on the top numerator, the highest power is 1, the low denominator is going to be 2. When this scenario exists, y is going to equal to 0. And so that concludes sort of my explanation based around the horizontal asymptotes. Be aware, I do want to side note this, that like for example, let's say we talk about a question like this and 5x and 3x squared are switched. Be aware that it does not change the highest possible power. That for this scenario, even if 5x and 3x squared are different positions, 3x squared, the 2 from that x squared is going to be the highest in this scenario specifically. And so make sure you understand that. But that being stated, I am now going to go ahead to the last concept for today, which is around slant asymptotes. So when we talk about slant asymptotes, and I'm going to switch papers for this, so there's a specific condition that must be met in order to create slant asymptotes in the first place. So for slant asymptotes, slant asymptotes can only exist and I'm going to write this out for you. If numerators greatest power is one value higher than the denominators greatest power. Okay, and as usual, I'm going to provide an example just to explain what I mean by this. So example. So if I was given a question like, I don't know, I'm going to make it up, 2x squared plus 3x plus 1 divided by x plus 1. Okay, the first thing first is this. So when I notice the highest power here is 2 and the highest power here is going to be 1, first thing first, you should remember that there is going to be no horizontal asymptote. Right off the bat, you should know that there is no horizontal asymptote. But that is not when I'm done, because if you notice, 2 is 1 greater than 1. And so that means that there is going to exist a slant, or I forgot to also mention, oblique asymptote that does exist. And so for this question, the way you're going to be able to get this value, the oblique or slant asymptote, is that you are actually going to divide the values, whether it's synthetic division or just long division. Personally, for me, I always do long division, but you know, preferences exist, so you could do synthetic for this. That's up to your choice. And so right here, I'm going to do, you know, division. So I'm looking to see what multiplies here to put up to here. 2x will, so 2x squared plus 2x will be here. I'm going to subtract these cancel out. 3 minus 2 is x plus 1. Oh, look at that. So it would be plus 1. Okay, so x plus 1 equals to 0. And I do want to mention a few things. So usually questions do not usually have a remainder that equals to 0. Usually it might be like a value, like there might be a 5 here, there might be a 10 here, there will be a remainder usually. If there is a remainder, even if there is a remainder on the question, you ignore the remainder and you only take the top value right here. So even if there's a 5 here, I ignore it. I know as a fact this is going to be my slant asymptote. Okay, so y equals to 2x plus 1 is my slant asymptote or oblique asymptote. I need to keep remembering to just include that value, that term, just in case you want to remember it based on that. So be aware that that's how you go ahead and find the slant asymptote. And of course, the way you're going to graph it for slant specifically is that you're going to actually graph 2x plus 1 as if it's like a normal line sort of thing. But of course, it's going to be a dotted line, which is going to represent the characteristic of an asymptote. So 1, 1, 2, 1, 2, whatever not. That's not a perfect sketch, but you get the idea that I'm going to create this, and that's how it's going to help me find the slant asymptote. It will look something like that. Okay, and so this is my explanation based around asymptotes in general, how to find them for specifically these type of polynomial based or fraction based equations. Please do subscribe to our YouTube channel or like our Facebook page. We'll continue to make content like this just to help you guys out. And so I hope you have a wonderful day.